Okay, now let's see the general physical properties of transition element. Alright, in general properties, okay, I will explain of atomic radius, density, melting point and boiling point, ionization energy, okay, and electrical conductivity. Alright, okay, we take a look for the atomic radius first. Alright, so now is the trend of atomic radius. Okay, refer to the graph. You can see that it's decreasing across the period. Okay, the red box here, this one is referred to the potassium, calcium. Okay, which is, if you can see that the pattern of the graph for metal group 1 and group 2, okay, it's more cheaper here. It's decreasing, higher decreasing. So means that the size of potassium, calcium is greater compared to the transition element here, which is the graph pattern more flattened. Alright, okay, so okay, the blue box is referred to the transition element. Okay, when you see that the size become decreasing. Alright, okay, why this is happen? Okay, the first one, okay, the deep block element shows a linear variation in their atomic radius compared to period 2 and period 3 element. Alright, why? Okay, from titanium to copper, okay, the number of proton increasing. Okay, so what happened is the nuclear charge increase. Okay, at the same time, the attraction between nucleus and electron cloud become stronger. So that's why the size decreasing, okay, across the period. Okay, however, the electron is added to the 3D subshell. Okay, that one is referred to the transition element. We just added the electron to the 3D subshell. Okay, as a result, okay, the effective nuclear charge increasing only slightly. Can make a small change in atomic radius. So that's why for transition element, the curve only slightly decreasing. Okay, alright. So here is the trend of atomic radius of transition element. Okay, now the second physical properties is a density. Okay, let's see the density. Alright, so here is the graph of density. Okay, if you can see that the graph become increasing. Okay, almost increasing. Okay, except for here lah. Okay, but we just see the, so okay, what is density? Okay, density is a mass over volume. Okay, what happened is, right, the density increasing gradually across period. Okay, and then, okay, why? Okay, due to the presence of strong metallic bond. Okay, so the structure is tightly packed in solid lattice. Alright, so that's why the volume become lower. So because it very tightly packed, okay, in solid lattice. So because of its tightly packed in solid lattice, okay, so what happen is, okay, volume, okay, become decreasing. Right, next one is okay, although the atomic radius does not change much, but the RAM, which is relative atomic mass, increase gradually, okay, when across the period. So because of its increasing, so what happen is, so the mass here, okay, it will increasing, okay, across the period. So that's why density become increasing when across the period. Okay, because of the very small difference in the energy of 3D and 4s subshell, okay, here, okay, so it make use the outer 4s as well the inner 3D electron to form metallic bond. Okay, so this one is referred to the field electron configuration. So it has orbital here actually. Suppose it contains electron. So okay, because of the small difference here, so in formation of metallic bond, it involves both orbital, which is 4s orbital and 3D orbital as well to form metallic bond. Alright, so for transition element, they have large number of electrons available for the strong metallic bond to be formed. So it will involve these both orbitals to form metallic bond. Alright. Okay, so why transition element is a very higher melting point and boiling point? Okay, because the presence of the strong metallic bond. Okay. Okay, next physical properties, okay, is ionization energy. Alright, so for ionization, the first, second, okay, and third ionization energy for the first transition metal. Alright, so if you can see that it's only slightly increased across the period. So if you can see that the increasing is only slightly different. Alright, for the second and the third, okay, except if you see that they have some exception here, okay, which is for the third one for manganese, and for second transition element is for chromium. Okay, what will happen? Okay, why this is happen? Alright. Okay, for chromium, okay, we will remove the first one, okay, first electron from 4s orbital, so lower energy. Okay, and then for second electron, okay, second IE, okay, we will remove the electron from the 3d5 orbital. Alright, okay, so same as the manganese, which is this 3d5 is a half-wave orbital, which is the most stable orbital. So that's why in order to remove the second electron in a chromium, okay, in a 3d5 orbital, higher energy needed. So that's why the IE of chromium is slightly higher compared to the other element. Alright, okay, and then for the first IE, we can see that it's only slightly increasing. Okay, so okay, as a conclusion, okay, this transition element has a low IE, okay, except this element. Okay. Okay, for the last physical properties is electrical conductivity. Okay, let's take a look. Alright, so now is, okay, across the period, we can see that the electrical conductivity is getting increasing. Okay, why? Okay, for the first thing, okay, when we said about electrical conductivity, we must refer to the localized electron and refer to the valence electronic configuration of transition element. It consists of 3dx and for S2 or for S1. Sorry, ini for SL. This one is the for S1. Alright. Okay, so refer to the transition element of its valence electron. It have higher delocalized electron. Okay, compared to group 1 and group 2 metal, which is it have higher delocalized electron. So what happened is, okay, it has higher electrical conductivity because of the greater delocalized electron. So for transition element, it have higher electrical conductivity compared to metal of group 1 and group 2. Alright, so we have done covered the physical properties of transition element. Okay, as a conclusion, we can say that across the transition element, atomic radius and melting point, okay, are decreasing. Okay, while for density, ionization energy, and electrical conductivity are getting increasing, okay, when across the period. Alright, so thank you.